Hello everyone. Welcome to week 4. Congratulations, you've made it halfway through. This week we're going to study the order of operations and solving some simple equations. So let's begin. Alright, we've already looked at the order of operations. The order would be to solve anything inside the parentheses first, which means any kind of operations that you can simplify inside the parentheses, you would. Next, you use get rid of your exponents, and then your multiplication or division. Now, if you have both multiplication and division within an expression, you would do whichever one comes first as you go from left to right in the expression. Same thing with addition or subtraction. If you have both of those in your expression, you would do whichever operation comes first as you go from left to right. Okay. So let's look at this one. Find the value of 12 minus 32 divided by 2 over 3 plus 2 over 5. So the first thing we want to do is to work inside the parentheses here and simplify this. So remember, to add or subtract fractions, we have to have a common denominator, which is the common multiple of the denominator. In this case, the first common multiple of 3 and 5 is 15. So I would change my denominators to 15. And remember, if you change your denominators, you have to change your numerator. So when I change this first denominator to 15, I had to multiply by 5. I need to multiply the top number by the same thing. So that would make 10 over 15. The second one, I had to multiply by 3. So I need to multiply the top one by that same 3 to keep it equivalent, and that would make 6 over 15. Okay, now that I've done that, I can add my numerators and keep my denominator. Now I have 16 over 15. Now my next order, since I've simplified as far as I can inside the parentheses, would be to divide in this case. I have subtraction and division. In my order of operations, division would come first. So I'm focused on this 32 divided by 16 over 15. And this is the same thing as dividing fractions. So I will keep this first number as it is, change my operation to multiplication, and then flip the second fraction. Now it may help to write that 32 over 1 so you can see that 32 can be a fraction if you place it over 1. Now in multiplying these two fractions, you could go ahead and multiply top times top and bottom times bottom and get your answers and then simplify. But you can also simplify before you multiply those. And the way you would do that, you would look at numbers that are on top of fractions and that are on bottom of fractions and see if there's anything that will go into them. For example, with this one, if I look at 32 and 16, I know that 16 will go into both of these numbers. So I can divide both of those by 16 to simplify. So 16 divided by 16 would give me 1, and 32 divided by 16 would give me 2. So now what I have is 12 minus 2 over 1 times 15 over 1. And then I can multiply those. 2 times 15 is 30. 1 times 1 is 1. So that's 30 over 1, or just 30. And then I need to remember my rules. So if I'm subtracting integers, I keep the first number as it is, change to plus, change the sign of that other number, so that's 12 plus negative 30. Take the difference of the two numbers since they have different signs, and the difference between 12 and 30 would be 18. And in this case, I would take the sign of the number with larger absolute value, which is 30, so it would be negative 18. So again, going through my order of operations, work inside the parentheses first, divide second, and then do my subtraction. Okay. All right, let's look at another one. 8 divided by, and then in parentheses here I have 1 divided by, and then parentheses here 1/4 plus 1/4 to the third power times 2 squared, all in parentheses. So the first thing I see are my two outer parentheses. So I'm going to work inside here, and then I find more parentheses inside that I need to simplify first. So I'm going to work at the innermost here, as far inside as I can, which would be the 1/4 plus the 1/4. I can simplify that. So I'm going to use my order of operations inside my parentheses. So I'm going to have 1 divided by, and then 1/4 plus 1/4. They already have a common denominator, so I just add my numerators, makes 2/4, and then times 2 to the second. Okay, I can simplify that fraction because 2 over 4 is the same thing as 1/2. Okay, next, inside my parentheses, after parentheses, I've worked inside as far as I could. I need to get rid of my exponents. Now remember, the exponent tells you how many times to multiply a base times itself. So 1/2 times 1/2 times 1/2, if you multiply the top numbers, that's 1 times 1 times 1, which is 1. The bottom numbers, 2 times 2 times 2, is 8. And then 2 squared, or 2 times 2, is 4. Alright, still working inside the parentheses using my order of operations. Now again, I have division and multiplication here. So my order of operation tells me to do whichever operation comes first. So the first thing I need to do is 1 divided by 1/8. And remember, to divide fractions, we keep the first number the same, change the multiplication, and flip the second number. So that becomes 8 over 1, or just 8. Okay, so 1 times 8 is 8. 8 times 4 is 32. Now I've gotten down to this point. I've worked inside my parentheses using the order of operations inside here to get all the way down until I get one number where I can't simplify it anymore. So now I have 8 divided by 32. Now this is different from 32 divided by 8. 32 divided by 8 would be 4. 8 divided by 32, since I cannot do that evenly, I'm going to write it in fraction form and write 8 divided by 32 in fraction form. And then I would see if I can simplify that. So what I know is that 8 will go into both of these numbers. So if I divide both the top and the bottom by 8, and I have to divide top and bottom by the same number to keep the fraction equivalent. So if I divide both of those by 8, I end up with 1 over 4, or 1/4. Okay, so again, we started with the innermost parentheses to simplify that. We got 2/4, and then I reduced the 2/4, or simplified that fraction to 1/2 because 2 would go into both of those numbers. And then I use my exponents. 1/2 times 1/2 times 1/2 is 1/8, and 2 times 2 is 4. And then I know I have to divide first, since this comes first, but to divide fractions we keep the first number the same, change the multiplication, flip the second number. So I ended up with all multiplication. So I had 1 times 8 is 8, times 4 is 32, and then wrote 8 over 32 and simplified it. Okay. All right, let's look at one more of these. In this one we have 4 to the third minus 2 divided by -2. So I want to start inside the parentheses and use my operations inside the parentheses until I get it simplified. So I'll do 4 to the third power first, which again, that means 4 times 4 times 4, which is 64. And then we'll keep working inside the parentheses until we get it down to one number, or as far as we can. And 64 minus 2 is 62. Now I dropped my parentheses off because I have simplified it as far as I could, and I didn't have anything on the outside of the parentheses here. So I can drop the parentheses off. Now all I have left is 62 divided by negative 2. Now keep your rules in mind. When you multiply or divide a positive and a negative, your answer will be negative, and then you will divide as usual. So 62 divided by 2 is 31. Negative 31 will be my answer. Okay. Okay, let's try this one. I'm going to start inside the parentheses, use my operations in there first until I get it down to one number. So I would have to start with the exponents there. And 3 squared is 3 times 3, or 9. Okay, still working inside the parentheses. I can add those numbers together. 2 plus 2 is 4, plus 9 is 13. Now you have to figure out what you would have to do next. So I'm looking here. I've simplified that as far as I could, and I got 13. I have 2 minus 13 times 6. My order of operations tells me to complete the multiplication first. So I would need to multiply those two numbers first. So 6 times 13, 78. And then I have 2 minus 78. So remember, that's the same thing as 2 plus a negative 78. So that means I would have to find the difference of the two numbers, which is 76, and take the sign of the number with the higher absolute value, so my answer would be negative 76. Exponents, add to get one number inside of here. And once I get that one number, I use my order of operations all over again on the whole problem, which in this case tells me to multiply and then subtract. Okay, so let's move on. All right, equation rules. Equation rules, you have an addition and subtraction rule that says the same quantity or the same number can be added or subtracted to or from both sides of an equation, and the equation will stay balanced. Multiplication and division rule says the same non-zero number can be multiplied or divided by each side of the equation, and the equation will stay balanced. It's okay. So the golden rule, whatever you do to one side of the equation, you must do to the other to keep it balanced. So you can think of an equation as a double scale weighing device, where you have to add or subtract the same thing on both scales to keep it balanced. Same thing with an equation. So let's look at a few equations. Now some of these may be in word problems, and you'll just have to set them up. This one says twice a number is decreased by 7. Twice, 2 times. Decrease means subtract. The result, which means equal, is 13. What is the number? Well, the first thing we want to do is define the number. So we'll let x equal the number. Let it be the variable x. So to write that out, twice a number, or 2 times x, is decreased by 7, or minus 7. The result is 13, equals 13. Now my goal is to undo this equation and end up isolating x, get x by itself. So I'm working on the left hand side of my equation to undo this side. So I'm going to start with the minus 7, 2x minus 7. The opposite of minus 7 is plus 7. And the reason I do that is because negative 7 plus 7 is 0, and that's my goal, is to eliminate that 7 from over here. But whatever I do on the left side of my equation, I have to do the same thing on the right hand side of my equation. We'll keep the equal sign there. 13 plus 7 is 20. And I have 2 times x equals 20. Now I want to undo the 2 times x. And the opposite of 2 times x is to divide by 2. And the reason I can do that is because 2 divided by 2 is 1, so they will cancel each other out. Then I would have to come over here and divide by 2 also. So that gives me x equals 10. Now you can always check your answers in equations. And you can check your answers by taking the solution you got and plugging it back into your original equation to see if the sides balance out. So if I take that 10 and replace x with it, sorry, that should have been a 7 there. So 2 times 10 minus 7 equals 13. And I'll work this side out, simplify it using my operations. I would do 2 times 10 first, which is 20. And 20 minus 7 is 13. So that checks out. So that's how you could check your answer, by taking your solution, plugging it back in for your variable. Okay. All right, what about this one? Half of a number is decreased by 5. The result is 35. So half of a number, or 1/2 times x, or x divided by 2, is decreased by 5 minus 5. The result is 35. So this problem is very similar to the last problem. X divided by 2 minus 5 equals 35. Again, we define the number as x. Now, x divided by 2 minus 5. I want to undo the minus 5 first. And I'll do the opposite of minus 5, which would be to add 5. Again, the reason I do that is because negative 5 plus 5 is 0. They cancel each other out. 35 plus 5 is 40. So I have x divided by 2 equals 40. Now listen to the key words. I have x divided by 2. To undo x divided by 2, I want to multiply by 2. Or 2 over 1, same thing. And again, as I showed you in a few slides before, the reason we do this is because the 2's will cancel each other out. So whatever I do over here, I have to come over here and do the same thing. So I need to come over to the right hand side and multiply by 2 also. And I end up with 80. Let's check that answer out and see if it holds true. 80 divided by 2 minus 5, we're saying that equals 35. And again, I just replace the x with my solution of 80. 80 divided by 2 is 40. And 40 minus 5 is 35. Checks out. Okay. What about this one here? We have a number is 7 times another number. When the numbers are added plus, their sum is 40. What are the numbers? Well, the first thing you want to do is to define your numbers again. So, like I did on the slides before, I'm going to let x equal my first number. Now, I know something about the second number, it says a number is 7 times another number. So the second number is 7 times the first number. And it tells me that when I add those two numbers together, the first number of x, the second number was 7x. When I add those two numbers together, the sum of those numbers would be 40. So 1x plus 7x equals 40. Now this is called like terms. Since both of these have x, I have 1x and then I have plus 7x, I can combine those to make 8x equals 40. And remember, this is really 8 times x, so if I want to isolate my x now, to undo that, I would divide by 8. And that shows me that x is equal to 5. Now remember what x represented. X represented the first number. So my first number is 5. That's my first number. My second number was 7 times x, or 7 times 5, because my x is equal to 5. So my second number was 35. And as you can see, it says when the numbers are added, their sum is 40. So my first number of 5, second number of 35, 5 plus 35 is 40. So those would be my two numbers. So again, you need to make sure you define your numbers first and then set them up in the equation using the information that you're given. Okay, round to the nearest hundredth. Now to round a decimal number, first thing you want to do is find out what they want you to round it to. So in this case we have 0.7385. So the digit that is in the hundredths place is the 3, right there. So we have to make sure we look to the number at the right of that number to see if we need to round this 3 up to 4 or leave it the same. Now if the number to the right is 5 or higher, then we would round the number in the hundredths place up. If this number is lower than 5 or less than 5, then we would leave it the same. But in this case, since I have an 8 there in the thousandths place, then that tells me to round the 3 up to a 4, and I would have 0.74. So we find the place, the digit in the place that we asked to round it to. We look to the right of it to see if we need to round that number up or leave it the same. Okay, solve this equation. So again, our goal in solving equations is to isolate the variables. So this one is pretty simple. I have x, or some number, plus 5 equals 8. Now you might be able to mentally replace that x with a number and know what it is. But let's go through the process of how to solve the equation, so when you have something tougher, you'll know how to solve it. We're trying to undo this side to isolate x. So x plus 5, I want to do the same thing or undo it and subtract 5, because positive 5 and negative 5 is 0. It cancels out. Then I want to come over here on the right hand side and do the same thing, subtract 5. And that tells me that x is equal to 3. Okay. What about this one? 3 times some number equals 36. Well, you probably already know that that's 12. Let's see how to undo the problem. 3 times x equals 36. To undo 3 times x, I'm going to divide by 3. Because 3 divided by 3 is simply 1. They cancel each other out. And I'll come over here and divide by 3 also. 36 divided by 3 would be 12. Okay, what about this one? X divided by 3 equals negative 7. Well, I want to do the opposite of x divided by 3, so I want to multiply by 3. And remember that 3 is the same thing as 3 over 1. And this uses the principle that I can simplify those 3's there because they cancel each other out. But whatever I multiply by on the left-hand side, I have to multiply by on the right-hand side. So I need to multiply my right-hand side by 3 also. And a negative times a positive makes it negative, so I have x equals negative 21. And again, you can check this. If I replace x with negative 21 divided by 3 is negative 7. Okay, what about this one here? Let's read through it. It says a vendor is selling hot dogs at $3 per hot dog. So we know every hot dog is $3 a piece. The vendor made $72 in hot dog sales. How many hot dogs did he sell? Well, let's let x equal the number of hot dogs sold. Okay, so what we know is that each hot dog costs $3. And at $3 per hot dog, the vendor made $72. So let's see, how many hot dogs did that vendor sell? Now that we have our equation set up, we can easily solve it. So I have 3 times x. I want to undo 3 times x by dividing by 3. And then 372 divided by 3. Oh, that's bad math there. Let's try that again. $24 hot dogs. The vendor sold 24 hot dogs. Okay, so you set up your equation and solve it. All right. This is the end of this show. Again, congratulations. You've made it through the first 3 weeks. You only have 3 left. So continue to work hard and keep up the good work.